So we have finished two models in graphical method. I will discuss the third one. I have already told what is the third model. We will take objective function is either maximum or minimum, anyone. Okay, and constraints both less than equal to as well as greater than equal to mixed constraints. Then we know how to solve the problem by using graphical method. Same steps, 6 steps will be as it is. So first I will dictate the problem, write down the problem, solve the following LPP by using graphical method. By using graphical method. So in this problem, objective function is given minimum. You may get minimum problem or maximum problem, no problem. Mix means you may get either a maximum or minimum. Okay. So minimum z equal to 20x1 plus 10x2. 20x1 plus 10x2. Okay. And now write on the subject to the constraints. Subject to the constraints. Write on the constraint. First constraint x1 plus 2x2 less than or equal to 40. x1 plus 2x2 less than or equal to 40. Second constraint 3x1 plus x2. 3x1 plus x2 greater than or equal to 30. Greater than or equal to 30. Third constraint 4x1 plus 3x2. 4x1 plus 3x2 greater than or equal to 60. 16. Greater than or equal to 60. So how many constraints are there? Constraints means inequalities. How many inequalities are there? 3. So how many constraints will be there? 3. But how many decision variables are there? Only 2. If you observe x1, x2. So that means and x1, x2 greater than or equal to 0. So this is the problem. So if you clearly observe, objective function is minimization is given. Constraints is a mixed constraints. Less than equal to is there as well as greater than equal to is there. Mixed both. Both are there. And x1, x2 greater than equal to. These are non-negative statements. So that's why you have to take the first quadrant. So the feasibility should be calculated in identified in the first quadrant. Okay. So the same procedure. Any problem in graphical method, the same procedure. So this particular problem, for this particular problem, you can apply graphical method. Yes, you can apply. Why? How many decision variables are there? Only 2 are there. Means 2 decision variables means you can solve that particular LPP by using graphical method. So write down step number 1. Step number 1. What is step number 1 in graphical method? Already I have been third problem. What is step number 1 in graphical method? Convert all the inequalities into equality constants. All the inequalities, whatever will be the inequalities, either less than or equal to or greater than equal to, it should be converted as equal type constraint in step number 1. Okay. So right. So convert the inequality type constraints into equality type constraints. So I am converting inequalities into equalities. So how many equations will we get? 1, 2, 3 equations will we get. 3 equations will we get. Okay. So I am converting inequality constraints into equality constraints. So step number 1 is complete. What is step number 2? Already you are done third problem. What is step number 2? Plot these equations on the graph, as each one will geometrically represent a straight line. If you want to plot these equations, you require the points. And first you have to identify the points for these lines, and after that you can plot the equations on the graph by using the points. Okay. So step number 2. Step number 2, write a plot here. Plot each equation on the graph. Each equation on the graph as each one will geometrically represent a straight line. As each one will geometrically represent a straight line. Then we get. So consider equation 1. First we have to consider equation number 1. So in that equation number 1, put x1 equal to 0. Put x1 equal to 0. This is equation number 1. x1 equal to 0 means what we get? 2x2 equal to 40. That means what is the x2 value? x2 value equal to 40 divided by 4. That means 20. 20 is the value. And then in the same equation, put x2 equal to 0. x2 equal to 0. In the same equation, x2 will be 0 now. That means x1 equal to 40. x1 equal to 40. That means what is the first point? We got first point x1 value. What is x1 value? 40. x2 value. What is x2 value? 20. So first equation point is 40, 20. Similarly, repeat the same procedure for the remaining 2 equations. Okay. So consider equation 2. Next slide. Consider equation to put x1 equal to 0. Put x1 equal to 0. This is equation number 2. Put x1 value equal to 0. So x2 value equal to 30. This involves x2 equal to 30. X2 equal to 30. Same in the same equation, put x2 equal to 0 now. In the same equation, x2 value will be 0. That means what is it? What we get 3x1 equal to 30. That means what is x1 value? X1 value equal to 30 divided by 10. That means what is the point we are getting? Second point we are getting x1 value. x1 value is 10, x2 value is 30. Second point is 10 comma 30. Now equation 2 is completed. So repeat the same procedure for equation 3 also. Equation 3, consider equation 3. Equation 3, put x1 equal to 0. Put x1 equal to 0. x1 equal to 0 means what we will get? 3x2 equal to 60. This implies 3x2 equal to 60. 3x2 equal to 60. That means what is x2 value? We get x2 equal to 60 divided by 20. x2 value 20. Same in this equation only put x2 equal to 0 now. x2 0 means what we will get? 4x1 equal to 60. 4x1 equal to 60. 4x1 equal to 60. That means what is x1 value? 60 divided by 4. 60 divided by 4 means 50. So that means what is the third point? We are getting x1. x1 value is 50. x2 value is 20. Now I got the 3 points. What the first point we got? First point I got is 40 comma 20. First point is 40 comma 20. Second equation point is 10 comma 30. And third equation point is 15 comma 20. Now I can draw the graph. Because I know the 3 points: 40 20, 10 30, and then 15 20. If you go to this one, x1 what is the highest value? 40. x1 highest value is 40. x2 what is the highest value? 30. So scale 40 40 you can consider x1 40, x2 40. Okay. So now I will draw the graph. The same procedure. What you have done, only step number 3 is identify correct. So I will draw the graph now. This is x1 axis, the x2 axis, this is x1 axis. This is x1 and this is x2. Clearly this is origin both, and this is 40 objects, so 10, 20, 30, 40. x1 by 40, same as here, 10, 20, 30, 40. You can take 10 difference, 5 difference, your wish, you can consider it. So first point, 40, 20. x1 value is 40. x2 value is 20. 40, 20. Use the scale and join the points. This is equation number 1. Equation number 1. Next, second point, 10, 30. Second point is 10, 30. 10, 30. x1 value is 10. x2 value is 30. x2 value is 30. So join these points by using scale. This is line 2. Equation 2. Equation 2. Now the third one. Third point, 15, 20. 15 is the x1 value. This is x1, 15 midpoint. And 20 is the x2 value. This is 20. Now join these points here. Use the scale always. Use the scale and join the points. This is line 3. This one is line 3. You can indicate line 3. Line 3. Now I have indicated line 3. Okay. So I got all the strike lines. Now step number 2 is completed. Now step number 3 is important. Step number 3 is same. What is the step number 3? You have to identify the common region or feasible region. How will you identify the common region? If the constraint is less than or equal type, below the line is shaded. If the constraint is above greater than or equal to, above the line is shaded. Now see your first constraint. See the problem. I have given the problem. See the problem. First constraint is which type? Less than equal type or greater than equal type? Less than equal type. Less than equal type means below the line is shaded. So see the first line. This is the first line. This is the first line. First line is less than equal type. Less than equal type below the line. This is above. So first constraint is less than equal type means below the line is shaded. Below the line is shaded. Below the line is shaded. Next, second constant. Second constant is greater than equal to. Second constant is the second line. This is the second line. So the second line is greater than equal to. Greater than equal to means above the line. Greater than equal to means above the line. This is a common part here. Greater than equal to means above the line. Okay, above the line is like this arrow. Next. Now the third line. Third line is also greater than equal to. Third line is this one. This one is greater than equal to above the line. This is the line. Greater than equal to means above the line. This is the line. Greater than equal to means above the line. Now identify the common part. Common part is where all the lines will be there. So this part is common part. If you have three color pencils, just shade this one. If you have three color pencils, first one is less than equal to shade like this. Second one is greater than equal to shade like this. Third one is also greater than equal to shade like this. You will identify only this part. This part you will identify all the three colors. So this is called feasible region. All the three lines are there. So this is called feasible region. This is not a feasible region because why reason is the second line starts from here onwards. So second line won't appear here. This is also not a feasible region. No line is here. This is also not a feasible region because third line starts from here onwards above the line. So you will not get third line here. Okay, this is also not a common part because the second line starts from here onwards. So only common part is this one. This is the common part. So this is the common part. What are the edges are there? A. This edge is B. So next edge is this one C, and this is the common part. We have for C. So that means A, B, C, D. This part is called feasible region. If you draw the diagram carefully by using scale, you will identify easily. This is called feasible region. So A, B, C, and this is D. This is D. D part is this one. Intersection part. Both the lines. These two lines these two lines intersection part is D. Okay. So that is step number 3. What is step number 3? Step number 3 is A, B, C, D is the feasible region. A, B, C, D is the feasible region. So now you can write on step number 3. Step number 2 you can finish out. So this part is called the feasible region. If you have 3 color pencils, shade the regions. All the 3 colors will be there in this region only. If you want, you can check with the color pencils. Okay. So this is the common part for all the 3 lines. So what are the edges you are getting? A, this edge is B, this intersection part is C, and this intersection part is D. So A, B, C, D is the feasible region. A, B, C, D is the feasible region. Okay. Now step number 4 is important. What is step number 4? Step number 4 is you have to identify the corner points. Right? Step number 4. Step number 4. Identify the corner points of the feasible region. Identify the corner points of the feasible region. First corner point is A. A point all of them. A means where A is the x-axis only. X-axis point already over. What is x-axis point? A comma 0. That means A comma 0. A comma 0. A means what is the same value? The square value is 15. Between 10 and 20, this is 15. So 15 comma 0. 15 comma 0. Next. B point. B is also x-axis point. The x-axis itself is the x-axis is x1 axis. Okay. So B is also x-axis. So that means point is A comma 0. So that means what is this B value? B value is 40. So that means 40 comma 0. Now next one is C. Now carefully if you observe C, C is the intersection of this line and this line. So this line is 1 and this line is 2. And C is the intersection of 1 and 2. C is the intersection of 1 and 2. Intersection of 1 and 2. Remember it was the same what you have done in the previous problem. Only this is different. That's it. 1 and 2. Okay. So see the first equation. Already first equation is easy. What is the first equation? X1 plus 2x2. X1 plus 2x2 equal to 40. This is equation number 1. And the second equation. What is your second equation? 3x1 plus x2. 3x1 plus x2 is equal to value is that is 39. This is equation number 2. Solve the equations. Already all of you know how to solve these equations. There are a coefficients, x1 coefficients or x2 coefficients will be. So this into 1, this into 3, this into 1. You wish you can make it as either x1 coefficient or x2 coefficients. So multiply this, then what you get? 3x1 plus 6x2 equal to 120. This is into 1 means same 3x1 plus x2 is equal to 30. If you do subtraction automatically, x1 will be cancelled. So that means this is 5 5x2 equal to 90. 5x2 equal to 90. 120 minus 30, 90. So therefore x2 equal to, here I am writing x2 equal to 90 divided by 5. 90 divided by 5. x2 equal to 90 divided by 5. 90 divided by 5. That means what is the x2 value? So this implies x2 equal to 80. x2 equal to 80. x2 equal to 80. Now substitute x2 in any one of the equations. x2 in any one of the equations. So I will substitute in equation number 2. Equation number 2 1 or 2 your wish. So I will substitute in x2 value in equation 2. Okay. So right from 2 from second equation, what is that? 3x1 plus x2 value. What is x2 value? We got 80 equal to 30. This implies 3x1 equal to 30 minus 18. 30 minus 18 means what is this value? 12. 30 minus 18, 12. So that means x1 equal to x1 value. What is x1 value? x1 equal to 4. Now I got x1, I got x2. Which point this one? This is a part of C. Okay. So what is the C point? I have C equal to x1 value 4, x2 value 8. So C is nothing but 4 comma 18. C is nothing but 4 comma 18. Now A is completed. What is A point? I got just I am writing the points here. A point you got. What is the A point? You got 15 comma 0. B point you got. What is the B point? You got 40 comma 0. C point, just now we have calculated what is the C point 4 comma 8. Now only one left out, the D point. D point we have calculated. So I think you have finished this one, calculation part. Just I am calculating here D. Now D I will calculate. So D is also intersection of now see D is what? This is D point. Intersection of which one? This is third and this is second. So intersection of 2 and 3. Intersection of 2 and the second and third equations if you solve, you will get the D point. Now see second equation. What is the second equation? 3x1 plus x2 equal to 30. This is the second equation. What is the third equation? You have already 4x1 plus 3x2 equal to 60. This is equation number. Now same concept. Solve the equations. That means you can either equivalent to x coefficients or equivalent to x1 coefficients or equivalent to x2 coefficients. You can make it equal either x1 coefficients or x2 coefficients. Okay? So I will make it as equal to x2 coefficient. That means into 3. This is into 1. Now solve this equation. 9x1 plus 3x2 equal to 90. Next, this one is same. 4x1 plus 3x2 equal to 60. Now do the subtraction, automatically x2 will be cancelled. This is 5x1 you will get equal to, this is 30. 5x1 equal to 30. That means what is x2 value? x1 value will get x1 equal to 30 divided by 5. That means x1 equal to 6. x1 equal to 6. Now I know x1, I can substitute in any one of the equation, either second equation or third equation. So x1 I know, I will substitute in the second equation. From 2 to what is the second equation? Okay. From 2 3x1. Sorry, x1 I got now. 3 into x1. What is x1 value? 6 plus x2 equal to 30. That means x2 equal to 30 minus 18. That means x2 equal to 12. x2 equal to 12. That means I know the point now. What is the point? This is the D point. So D point I know what is x1 value 6, x2 value 12. Now I know all the points. D equal to 6 comma. Now I know A, B, C, D. Feasibility is A, B, C, D. I got all the points. Now I can go to the next step. Now step number 4 is complete. This is step number 4. I think all of you understood. This is the third problem we are discussing. Okay. Now we will move to step number 5. Step number 5. Now what is step number 5? Step number 5 is nothing but identify your objective function. Objective function is given as maximization or minimization. So minimization is given. So I can given that minimum z equal to what is given? 20x1 plus 10x2. 20x1 plus 10x2. 20x1 10x2. So what is the feasible reason? These are the parameters. Just substitute in the check. Wherever you find the minimum value, that's your answer. Okay. First I will calculate ZV. What is A point? A point is 15 comma 0. 15 comma 0. 20 into 50 plus 10 into 0. 10 into 0. That means what is this value? 300. Next I will calculate ZB. So what is the B point? 40 0. 40 0 means what is that? 20 into 40. 20 into 40 plus 10 into 0. So what is this value? 800. Next I will calculate ZC. What is the C point? C point is 20 into 4 plus 10 into 80. 10 into 80. This value is 80, this is 180. 80 plus 180, 260. 260. 260. Next, last value. What is the last value? ZD. ZD equal to 6 comma 12. 20 into 6 plus 10 into 12. This is 120, this is 120, 120, 120. Now your objective function is maximization or minimization. See your objective function. Objective function is minimization. Go for minimum value. What is the minimum value? What is the minimum value here? This is 300, 800, 260, 240. So 240 is the minimum value. So what is the answer for this particular problem? Particular problem answer is 240 at the point D. What is the D point? 6 comma 12. So by the last step number 6. Step number 6. Step number 6. Step number 6 is what is it? Right? The optimum solution. The optimum solution to the given LPP. Optimum solution to the given LPP by using graphical method. By using graphical method is minimum Z equal to 240. Minimum Z equal to 240 at the point. What is the point? At the point D. At the point D, what is the D point? 6 comma 12. At the point D, 6 comma 12. 6 comma. Okay. So I think all of you are now understanding more quickly compared to the previous problems. You will identify the problem very quickly and you can solve the graphical method because it takes less time to me also. Because first problem it takes some half an hour to explain. Second problem also half an hour to explain. The third problem, more practice. If you do more practice, you can complete within a less time. Okay. So this is the third one. So what are the models we have discussed? All are same models. All are graphical methods only. So in this way, I have divided into 3 parts now. 4 parts actually I have divided. First part is objective function is maximization. Constraints are less than equal type. You have solved that one. You know how to solve that one. Second one I have explained is objective function is minimization. Constraints are greater than equal type. Third one I have explained, objective function is either maximum or minimum. Suppose objective function is maximum, you will go for maximum rank. You will go for maximum. In this case it is minimum. Suppose sometimes you may get maximum, then you will go for maximum rank here. Okay. So now in this particular problem, objective function is a maximization or minimization. Third model I am saying. Objective function may be maximization or minimization. Constraints are mixed. If you observe these constraints, in this 1 less than equal type constraint is there, 2 greater than equal type constraints. But it is mixed. Less than equal to means below the line is shaded, greater than equal to means above the line is shaded. So you have identified the feasible region, and after that you have identified the corner points. You have identified what are the corner points of the feasible region. After that you have taken your objective function. You have substituted the corner points. Wherever you got the minimum value, because objective function is minimization, wherever you got the minimum value, you will identify that what is your answer for this particular problem. Okay. So I think I hope all of you understood graphical method well. So next class I will explain some special cases are there in graphical method or exceptional cases are there in graphical method. That topic one by one I will explain. There are 3 models are there, 3 special cases in graphical method: alternate optimum solution, unbounded solution, and infeasible solution. These are the 3 exceptional cases are there. But procedure is same. What is the procedure? Those 6 steps only. Okay. So first one I have explained, second model I have explained, third one is completed. Tomorrow or day after tomorrow I will explain what exceptional cases in graphical method. Exceptional cases I have already told. 3 exceptional cases are there in graphical method. One is alternative optimum solution. Alternative optimum solution means what is the same answer you may get at different points. Suppose here 240 you are getting, some this point also you will get 240. That is called alternative optimum solution. Okay? Same answer at more than one point. That type of solutions are called alternate optimum solutions. So next class I will explain the special cases one by one, alternate optimum solutions, unbounded solutions and infeasible solutions. One problem I will tell you. Then you can understand what do you mean by alternate optimum solution, what do you mean by unbounded solution, what do you mean by infeasible solution. Then this graphical problem, graphical method will be completed. Okay, so next we will move to the simplex method. So why the next method is invented, I will tell you. What is the drawback of this method? This particular method, graphical method, the drawback will be that this method is used only for two decision variables. Whenever three decision variables are there, suppose x1, x2, xt is there, you cannot solve by using that problem into graphical method. That's why the next methods are invented, simplex, we have two ways. I will tell you in detail later classes. Okay, so I hope all of you understood. You can practice some more problems in the exercise. If you have doubts, any doubts, you can call it.